Welcome back everyone. In today's session, we are diving into workload and scheduling, specifically how Kubernetes handles pod admission and scheduling. Stick with me because by the end of this video, you'll clearly understand the admission controllers like NodeRestriction and NamespaceAutoProvision, and scheduling strategies like NodeSelector, Taints and Tolerations, and pod anti-affinity. When you create a pod in Kubernetes, the request doesn't just magically run. It goes through a cycle, which includes authentication, authorization, and then admission control. And once the resource is being created, then comes the auditing portion. Now, Kubernetes API are accessed via kubectl command, client libraries, or REST request, following the sequence of authentication, authorization, and admission control. Two categories of users are there. The first one is service account that is managed by Kubernetes, and the second is normal user. The API server authenticates these users and their requests through certificate, password, and token. Then comes the Kubernetes role-based access control, which handles the basic authorization, a method for regulating access to resources based on the roles of the individual users within the enterprise. Then, admission control provides additional security, validating the pod specification like image version, rejecting the pods having root access, or mutating, which is modifying the configuration or making changes. Now, the admission controllers are very powerful. As we can see that there are two types of admission controller. The first one is validating and the second is mutating. And we can have the combination of both as well. Now, for example, NodeRestriction is a validating admission control. It ensures that kubelets cannot tamper with nodes or pods that they don't own. It doesn't change anything, it just validates and can reject the scheduling. Or it can just reject the command or the request. The second one is the NamespaceAutoProvision. It is a mutating admission control. If you try to deploy into a namespace that doesn't exist, this plugin can automatically create the namespace for you. This is now a mutation admission control because it's actually changing the cluster state. Now coming towards the live demo. First of all, we will see how the NodeRestriction validating control works. Now, first of all, we have to define the admission controllers in the Kube API manifest by mentioning an enable admission plugin. And first of all, we check the NodeRestriction plugin. Now, after making the changes, let's wait for the cluster to get online again. Now the NodeRestriction actually enables it ensures that the kubelets cannot tamper with nodes or pods that they don't own. It also restrict in the usage of certain labels as well. Now we will see it in practice. Now we have a worker node and named as node 01. Now first of all, giving the restricted label to the node 01, and let's see if we are able to label the node. As you can see, it is forbidden. It is forbidden by the pod admission control. Now let's try to label the control plane. Now this is something which is not owned by the node 01. Let's see if we can label the control plane or not. As you can see, we are not able to label the control plane because it is not owned by the node 01. So it was the validating control because the cluster didn't allow us to make any changes. Now moving towards the mutating control. First of all, checking as there is no, the namespace, and then scheduling a pod in a namespace which is not existent. Now we are not able to create a pod with the namespace blue because there is no namespace blue. Now making changes to the Kube API, the pod admission plugins, and mentioning here the namespace AutoProvision. Now what it will do, it will automatically create the namespace for our pod. Now waiting for the Kube API to be active again. Now, as you can see that Kube API is online. Now again trying to create the same pod with the namespace of blue, which is not existent. Let's wait for the Kube API to be active and ready. As you can see, we are now able to create the pod with the in the namespace blue, and the namespace blue is automatically being created. So it was a mutating control. First of all, we saw the validating, and now this is a mutating control. Now moving forward, now let's talk about the scheduling. By default, the Kube scheduler decides where to place the pods by filtering and ranking the available nodes. But sometimes you want control over where your pod should land. That's where the different scheduling strategies come in. One option is the node name. If you set the field in your pod specification, the pod is directly assigned to the node by passing the scheduler. This is a very rigid and usually only used for debugging or special static pods, because if that node is not available, the pod will stay pending forever. The next option is NodeSelector. This lets you tie your pod to nodes that have specific labels. For example, if you label your node with env equal to dev and put the node selector env dev in your pod specification, Kubernetes will only consider nodes that matches that particular label. It's simple and effective, but only does exact matches. Now we have the next one is Taints and Toleration. Here where things get interesting, the taints are applied to the nodes, they repel the pods. And tolerations are applied to the pods, they say, I can handle this taint. For example, if you taint your node with kubectl taint node 01 and env is equal to dev no schedule, no pod will land unless it has the toleration that matches with the node. So taints protect the nodes while toleration allows the pods through. Finally, let's look at the pod anti-affinity. This is all about spreading your pods. With pod anti-affinity, you can tell Kubernetes don't schedule these two pods with the same labels on the same node. For example, if your front-end replicas are all labeled front-end, the pod anti-affinity will ensure that they don't pile up on one node. Instead, they are all spread across the multiple nodes that are available to improve their high availability. Now you can also see the diagram. If you set the node name, Kubernetes force the pods onto that node. Otherwise, the scheduler looks at the node selector and node affinity to filter eligible nodes. Then it checks the taints and toleration. Only pod that tolerate the node's taints can proceed. Finally, rules like pod anti-affinity influence how pods are spread across the nodes. So the flow is, first of all, the Kubernetes cluster check the node name, then the node selector or node affinity, then taints and toleration, and then pod anti-affinity, and final scheduling decision is made accordingly. Now coming towards the live demo. First of all, we will start from the node selector. Now creating pod 1, and let's see what is the default behavior of the cluster and where the pod is being scheduled. Now the pod has been scheduled at on node 01. Now we want to change this scenario and we want to schedule this particular pod on the control plane. Now normally the control plane, no pods are being scheduled on the control plane. It only have the control components, but just for the sake of understanding the manual scheduling, we uses the node selector to schedule the pod on the control plane. So we define the a node selector value that is health equal to good, and also label the control plane with health equal to good label. Now let's see if the labels, the control plane has got the label or not. Now we are good to go. Now let us create another pod, and let us create the pod and see if we are able to schedule the pod on the control plane or not. And with the help of the node selector, we were able to schedule the second pod on the control plane. Now moving forward, in the next example, we will see the taints and toleration. Now you might have selected the node selector, but what if the control plane has taints and it repels some pod to be scheduled on them? So let us define a taint on the control plane, and let us see again if we are able to schedule the pod on the control plane or not. Now the taint has been successfully configured. Now again replacing the existing pod, and let's see how the taints work. Now you can see the pod is not now automatically scheduled on the control plane, because the control plane has the taints configured on them. Now to support the scheduling of the pod on the control plane, we have to define the tolerations so that the toleration matches with the taints, and we are able to schedule only specific pods with the specific toleration that matches to the taints to be scheduled on the control plane. And now configuring the toleration on the pod, we define the key, we define the operator, and then we define the effect. And now with exist, you normally don't configure the effects. Let's delete the effect. If I have used the operator as equal, then there would have been no problem with the configuration. But just for the sake of the experiment, let's just delete the effect. And now again scheduling the pod. Now let's see if after configuring the toleration, are we able to configure the pods? Yes, we are able to configure to schedule the pod on the control plane. And now let's see the toleration in the pod manifest. Yes, toleration has been defined. The key and the operator values are there. So it means that if the key is present in the pod, it can be configured on the nodes having the same taints. Now again checking the control plane as well and checking the taints. Now as you can see, the taints, the effect, the key is there and the effect is there. So in this way we define the taints and toleration. Now moving next towards the pod anti-affinity, which helps us to spread our pods. For example, there is a deployment, the configuration is there with you. There are 2 replicas, and we want to spread these 2 replicas. Like one pod should be scheduled on the node 01 and the other pod should be scheduled on control plane. So this is the configuration of pod anti-affinity, where the label is being defined. It means that the 2 pods having the same label should not be scheduled on the same node. Let's see if we are able to do the same. Yes, you can see now the first pod is being of the replica is being scheduled on the control plane, and the second pod is being scheduled on the node 01. And that's it. You have now got a solid grasp of pod admission and scheduling in Kubernetes. There's a quick recap. For example, for a node restriction is a validating admission control. The NamespaceAutoProvision is a mutating admission control. The NodeSelector targets the nodes. Taints and toleration protects the nodes. And pod anti-affinity spreads the pods for resilience. Now, if you found this useful, don't forget to like, share and subscribe, and drop your questions in the comments. I would love to help you out. Thanks for watching. Thank you.